this is Kaylee Gonzalez. I'm an application expert here with MLC CAD Systems. Thank you for joining me on this video. We are going to be taking a first look at SOLIDWORKS CAD. This video is intended for those of you who are new to SOLIDWORKS or have never worked inside of a 3D CAD environment. We're going to be covering some fundamentals in this video. We're going to be covering SOLIDWORKS part modeling. We're then going to document that model with a part drawing. Next, we're going to use that part model inside of an assembly. And then finally, we are going to go through an assembly drawing. The first portion is all about part modeling. We're going to see sketching, sketch relations, and how we can maintain design intent inside of our model. But before we jump into our part, we want to take a look at our design scenario. So what I have open is an assembly inside of SOLIDWORKS. We can see that it's definitely not complete. There's components missing. Now we can also take a closer look at what is missing internally by utilizing display states to hide a lot of external components. And here we can see we have this internal plunger, but no method of connecting it to the arm. And that's where we're going to start. We're going to create our document that's going to help link those items together. So as I go into my part environment, I'm going to see my initial starting point in SOLIDWORKS is going to be the front, top, and right plane as well as the origin. This is your fundamental starting point in all SOLIDWORKS projects. Now I'm going to create a 2D sketch, and this is going to be the generic profile or outline of my overall shape of my part. And immediately we can see reference lines, green boxes. These are a lot of visual icons and cues that help us maintain design intent through the green boxes and sketch relations. And then also we can add dimensions. This is going to turn my sketch from blue to black. The black sketches indicate they are fully defined, meaning that all degrees of freedom are constrained. This is recommended for the most robust parts, especially when dealing with downstream items such as assemblies. Now I can create sketch relations on the fly as you saw, or manually, such as this make equal, and then that's going to guarantee that this dimension is going to apply to both holes or circles. Once my sketch is done, I'm ready to turn this into a 3D part, and I'm going to use a mid-plane end condition to maintain symmetry. This is going to keep my sketch right in the middle and add equal material on both sides. From here, I can continue to round out the sharp corner on this particular part. Now, perhaps I'm not sure exactly what size this fillet is supposed to be, but Instant 3D allows me to dynamically click and drag to go through different sizes. And of course, I can change that size at any time. To create the cut going through the top of this part, I'm going to create a center rectangle. This is going to keep this symmetrical about the center of the part, and I'm going to constrain it to the side with a coincident sketch relation. This is going to compensate for any changes in the initial feature if this part has to go through any design changes. The third feature I'm going to do next is let's create our circle, and this is going to be the circular boss that's going to fit into the plunger that we saw in our assembly. Once we have the initial shapes completed, I can actually add additional information into my model, such as a cosmetic thread. Cosmetic threads allow us to choose our standard, the type, and the size, and be able to apply this information into the model for use with our drawings in the next section. Now, if I needed to add an undercut, perhaps this is something I use all the time. I can utilize commonly used items inside of SOLIDWORKS and drag them onto my screen and even change the size. This is a great way to leverage existing work inside of SOLIDWORKS. Now I'm going to need some hardware going into this circular boss, and this is where the hole wizard comes into play. I can choose my hole type, make sure it complies to a specific standard, choose the size as well as the end condition, and if I need to have specific cosmetic threads. Once my hole has been specified, I can easily place this inside the model. And a section view is going to show me exactly what this hole looks like. We're able to do a very unique hole in a very short amount of time. Think of the hole wizard like your machinist handbook. All that information is already built into the system. The last couple of items I'm going to do are fillets and chamfers to finish out this part. SOLIDWORKS allows for a variety of different types of selections, such as tangent propagation. This allows us to reduce the number of clicks and edges that we have to choose and still apply all our fillets and chamfers. SOLIDWORKS comes with a built-in material database with steel, aluminum, copper, many different types of materials, all with legitimate material properties. And we can easily apply these to the model itself to get weight and mass properties. Once our design is done, we can go ahead and save this design. We can create a file name, and we can also add a description directly into the custom properties of our model through the Save dialog. This is going to show up in items such as a bill of materials, which we'll see later inside of the assembly section. Inside of the part modeling, we saw how we can create a part from scratch. There's a lot of visual icons that help us maintain design intent and create our parts. We also saw items like cosmetic thread tools and the hole wizard. The next thing that we want to do is we want to create a basic drawing of the part that we had just created. So I'm going to go into SOLIDWORKS and I'm going to go under my new icon and make drawing from part or assembly. Once I choose my template, SOLIDWORKS is going to do quite a few things for me. It's going to load my title block, sheet size, and all of my orthogonal views over on the right. I can make use of drag and drop operations and projected views in order to place all of my initial views. Now I can change these views independently, such as making the isometric shaded with edges, or I can change them to be hidden lines visible to see some of those custom holes we created. Model items allows us to leverage all of those dimensions from sketches and features that we created in the model and dump them into our drawing. If we focus on the top view, we can create hole callouts for the hole wizard hole as well as the cosmetic threads. And this is one of the main powerful items of utilizing the hole wizard and the cosmetic thread tool, is because that information is already in the model. These very specific callouts are very simple to create. And of course, we can create and add any additional dimensions as needed. Let's take a look at our front view. Now we may have some cleanup to do since we added some information into the top view as well. No need to repeat information. SOLIDWORKS allows us to click and drag any dimensions and offers the ability to snap dimensions relative to each other. This allows us to line up dimensions, make sure that they are organized, and to create very professional drawings. Now I can add text to dimensions such as TYP for typical, and I can add different variety of tolerancing to my dimensions as well. So here I'm adding a bilateral tolerance, and we can see what this looks like inside of the graphics area. We can also make use of the SOLIDWORKS search bar in order to find other types of features that maybe aren't directly at our fingertips, such as this chamfer dimension. And I can make use of styles to just leverage the TYP so I don't have to manually type it in each time. Next, let's take a look at our right view. Again, we can do some initial cleanup and perhaps delete this 2 dimension because it is part of the chamfer that we just had specified. And what we're going to see here is that inside of the Smart Dimension in Drawings, we have some automation built in regarding the spacing of dimensions. SOLIDWORKS does an amazing job at not having overlapping dimensions when utilizing some of those automatic spacing tools. And of course, SOLIDWORKS is capable of having a variety of complex and additional views, such as section views, detail views, broken out section views, crop views. There's many ways and many tools available to further document this particular design. Once we have all our views created, we can save that drawing. And what we saw here was a lot of automation built directly into creating drawings. The drawing environment does leverage all that work that we did in our part environment, which is why we could bring in all of those dimensions in very little time. The next section that we're going to take a look at is the SOLIDWORKS assembly, and we're going to see how we can bring in our part file as well as run some simple evaluations inside of our assembly. Now that this drawing is completed, we can go ahead and close it down. I'm going to tile my windows vertically. This allows me to click and drag items from one window to another, and I can even automatically add mates. Mates are simply relationships inside of assemblies, relationships between components. And I can make use of smart mates using the Alt key to drag edges and faces together to further help create relationships. This allows me to stay very focused on the design by being able to utilize those smart mates. Now, I can go into my design library and take a look at maybe commonly used items, such as this link. The design library is where we can make use of common parts that we use at our company and simply drag them in. As we can see, I added my relationships, and that link is now connecting the arm and the new rod end part. We can do the same for this link. Now we can also make use of items such as configurations. Configurations were what allowed me to specify the diameter and the length of that particular pin. We're going to see it again on the snap ring. We can simply choose the configuration to guarantee that these items are going to fit together. Configurations are how SOLIDWORKS deals with families of parts, and they are set up by the user, but they can be very powerful, especially when we want to start inserting multiple instances of those components. So here I'm using a function called copy with mates. We're going to copy the mates relationships and the actual parts of that pin and the snap ring and add some additional instances. Now in these cases, these two pins are actually too long, but configurations allow me to access the list of different sizes, and these models can update inside of the assembly at any time. Now we've added quite a few pieces of information and different models. We want to be able to make sure that this spreader is not going to have any conflicts in its range of motion. So I can run a collision detection. This is going to show me faces highlighted in blue that are indeed colliding. And this is actually a big deal in a design like this because it will prevent these items from opening all the way. So fortunately, I can double click on faces, features, and dynamically change dimensions at any time, even while inside of an assembly. So as I run my collision detection again after changing the angle on that arm, we can see that that issue has actually been resolved. This is a phenomenal evaluation tool that SOLIDWORKS has, is the ability to double check work in the middle of designing so that our designs are going to be as accurate as possible right from the beginning. To finish up this design, I'm mirroring all of those additional components across the front plane. This is going to not only mirror the components, but also include those relationships. The mirror tool in Assemblies also allow you to create opposite hand version parts as necessary. When I turn on my display state so that I see all of my components, I can then go into my exploded view. Now the exploded view has already been started, but we need to update it with all of the different items that we have added since working on the exploded view. So in SOLIDWORKS, I can use my orange triad to move items so that they are all visible. This is something that is going to be leveraged in a drawing, so think of adding balloons to this. We want to make sure that everything is going to be visible and that our documentation is going to be as clean as possible. And we can certainly do that here by utilizing these custom exploded views. Once we were able to finish this exploded view, we're actually ready to talk about our drawing. So inside of our assembly, we saw how we can easily add components to our assembly, easily create mates and relationships using a variety of methods, including smart mates. We also saw one of many evaluation tools called collision detection that can help us find small errors even from the very beginning of our design. The next thing we're going to take a look at is creating an assembly drawing. We are going to utilize that exploded view we just finished, and then we're also going to insert a bill of materials and discuss some auto ballooning as well. Now I'm going to create a drawing the same way that we saw previously. Make drawing from part or assembly, and then choose my template. SOLIDWORKS is going to populate my sheet size as well as all of my views, including my isometric exploded view, which I can click and drag onto my sheet. Now this came in a bit small. I'm going to change it to shaded with edges and then also increase the scale. I want this to be a little bit larger so we can easily see all the small hardware included in this design. From here, I'm ready to go under my tables and insert my bill of materials. I can choose my template as well as the bill of material type, and I can insert this into my drawing and snap this into any corner that I want it to be placed in. If I were to take a closer look at the bill of materials, we're going to notice that I have columns for item number, the quantity is calculated, part number, and description, both of which are custom properties coming from the components and part files. Now I'm going to use an auto balloon in order to relate my model to the bill of materials. Now I like using the auto balloon because it's going to guarantee that I'm not going to miss any components inside of my design. When I bring in balloons using the auto balloon, it's going to make use of something called a magnetic line, which can allow me to move multiple balloons at once while maintaining spacing. Now, in some cases, we may want to drag items on or off of those magnetic lines, but they are a great way to help organize our balloons, especially if we have a series of small, tiny components. But this is customizable as well. We have a couple balloons still off the sheet, so we can go ahead and move these upward and adjust the spacing. Once completed, we can continue to bring in additional views, such as a top view. Now, the top view is in a closed orientation. We know that this model has motion built into it. We can make use of an alternate position view, which allows us to superimpose a configuration on top of an existing view. So we can actually see both a closed and open state, as well as be able to add dimensions so we can see what the largest open distance is between those arms. So that completed our assembly drawing. We saw again how we can utilize our assembly exploded view and then from there start leveraging bill of materials as well as ballooning and even creating additional custom assembly views. So we've done quite a bit inside of this design scenario. We took a look at part modeling where we saw quick modeling is very intuitive with all of the on-screen visualizations that can be used. We then documented that in a part drawing. We saw automatic tools to bring in some of the views as well as leveraging part model dimensions. We took a look at adding that part file to our assembly. We saw there how we can create mates and relationships. We saw how we can reuse geometry, make quick changes, and even do evaluations in the middle of our design. And then we concluded with our assembly drawing, which we were able to leverage exploded views, insert a bill of materials, as well as utilize configurations for things like those alternate position views. So I want to thank you very much for your time as you walk through this first look with me. There's a ton of information here, but please be aware this really is just the tip of the iceberg. If you have any questions about what you saw in this video, or if you're looking for any extended functionality like sheet metal, weldments, simulation, routing, please contact us at MLC CAD Systems. Our website is mlc-cad.com. We'd be happy to answer any questions you have or show you any additional functionality. So thank you very much and have a great day.